In this video, I'm going to show you how you can find the slope, or what's most commonly known as the rate of change. Okay, you'll see this phrase rate of change. Anytime you see that, that is the same as slope. So I'm going to show you two ways that you can find or calculate slope of a given graph. Okay, the first thing you need to do is choose 2 points that are on the line. Now, when you're choosing 2 points, you need to choose a point that is exactly on the y, along the y-axis, and exactly on the x-axis. So where the two corners meet or intersect. Okay, all of these points here are points on the line. Now, this point here, that is a point on the line, but if you'll notice, that number falls between 3 and somewhere in between 3 and 4 on the y-axis. That's not a good point because we can't estimate. We need exact numbers. So that red point isn't a good point to use. The black points line up directly with, if you notice, this point here lines up with 1 along the x-axis and -2 on the y-axis. This point here is 0 on the x-axis and -4 on the y-axis. And then this point here is 3, 2. Okay, so once you have points on your line, the first way you can calculate slope is to count rise over run. Okay, and to do that, what we do is we create or draw a right triangle between any two given points. All right, so if I draw and connect point 1, -2 and 3, 2, you'll notice that my rise is 1, 2, 3, 4, and my run is 1, 2. And 4 divided by 2 is 2, so that would be my slope. The other way to determine slope is using the slope formula, which is the difference of the y-axis divided by the difference of the x-axis. Okay, so using 3, 2 and 1, -2, remember we write our coordinates x, y. So my two y coordinates are 2 and -2, and my x coordinates are 3 and 1. Just be careful here. The formula means we have to take the difference of the two y values. So don't accidentally substitute in the -2 as the subtraction sign. So 2 minus a -2 will actually give me a +4. And of course, 3 minus 2 is 2. So of course, I do get 2. Now, some of you may be like, wait a minute, it says y2 minus y1. And that's not the order you put them in. Well, allow me to use the other, to switch the coordinates. So I'll do -2 minus 2 over 1 minus 3. Okay. Don't forget that when we subtract a negative, we have to add the opposite. So this gives me a -4 over, and 1 minus 3 is a -2. And 4 divided by 2 is 2, and because I have two negatives do make a positive. So therefore, that is also 2. So it doesn't matter the order, which x, y value you put first and which y value you put second. You're still going to end up with the same answers. Okay. Now here, if you'll notice, the first thing that should catch your eye is that this is a negative sloping line. Okay. So, and we have a point here. And unfortunately, my only other point that gives me a whole number location is this point here, which is at 5, -3. And this here is at 0, -1. So go ahead, stop the video, and see if you can, using either rise over run or the slope formula, find the slope of this particular line. Okay, so hopefully you were able to get an answer for this as to whether the slope or rate of change value is. Now here, you'll notice if I count my rise over run, I actually counted down 2 units. 1, 2. I went down, so that value needs to be negative. And my run, 1, 2, 3, 4, 5, went to the right, so that's positive. So I have a slope of -2/5. Now, if you use the slope formula, remember, it doesn't matter which values you mark, x2 and y2. Okay. So let's see, my first y value is -1, and then I have to subtract my second y value, which is a -3. And then my x values are 0 and 5. Okay. So when I subtract, I add the opposite. So this is going to give me a +2, and 0 minus 5 is -5. So these are the same, even though when you counted rise over run, the negative is with the 2, and using the slope formula, the negative's in the denominator with the 5. It's still the same answer because a negative divided by a positive is a negative. So I can rewrite this as -2/5 just with the negative in front. So those values are actually the same.